Here's my long overdue video of going through section 1 of the latest test, test 2. So this section covers lessons 2A and 2B. So if you want to retake this, in addition to correcting it along with me, you need to do the homework for those sections. You also need to do that part of the test review and bring those things and show them to me when you show up to do the retake. Okay, so here we want to explain why each of these is not a function. Hint, they're not functions. And then part 2, we want to change it in some way so that it would be a function. Okay, so why is this not a function? Well, it's because there is an input that has 2 outputs. So that's what I'm going to say. One input with 2 outputs, or with more than one output. Okay, so remember a function, for each input you only get a single output. Here we've got more than one output, that's not a function. And if I wanted to be more specific, I could say one input, such as 3. Or I could say 3 has 2 outputs. Or I could say, hey look, 3 shows up twice with 2 different y values. There's one x value with 2 different y values. Something like that. So let's change that. So what I'm going to do is just take out the second output that we get from 3. There. Now we only get one output from 3. Okay. 3. Here the idea is the same, although I'm going to use the vertical line test. Vertical line test. In other words, each vertical line represents an input, and then where it crosses the graph more than once represents more than one output for that input. So it's not a function. So to make it a function, I might flip it this way. Now it's a function. Here. Why isn't this a function? Well, because if I solve it for y, I'm going to end up with a plus or minus. Why? Because of this y to the 4th, and also because of this y squared. So I've got even powers. That's another thing I might say. Even powers of y. That's a problem. So how would I make it a function? Well, I could just simply take out those 2 terms with even powers. Now it would be a function. Okay. Or I could switch the x's and the y's. Some people did that. This would be a function. It's okay to have x to an even power, but not y. Okay. Number 7, g of negative 7 means we're going to use the function g, that's this one, and we're going to replace x with negative 7. So that's 4 times x, which we're replacing with negative 7 minus 4, which is negative 28 minus 4, negative 32. Okay, number 8. We want to look at this one carefully. So here I've got 3 times f of 2. Okay, what's f of 2? Well, so here's 3 times f of 2. F of 2 would be plugging 2 in to the function f. So it's going to be negative 2 times 2 squared instead of x squared, plus 3 times 2 minus 3. And whatever I get from that, I'm going to multiply it by 3. Plus g of 2. What does g of 2 mean? It means take the function g and plug in a 2. So that's 4 times 2 minus 4. Okay, so what does that give me? I can just plug it all in my calculator if I want, or I can do this in my head. So 2 squared is 4, times negative 2 is negative 8. 3 times 2 is 6, 6 minus 3 is 3. So that's negative 5 times 3 is 15 for this left-hand side. And then on this right-hand side, that's 8 minus 4, which is 4. So 15 plus, sorry, this is negative 5 on the left-hand side. So that's negative 15 when I multiply it by 3. 3 times negative 5, negative 15. Plus 4 equals negative 11. F of x plus 1 minus f of x. f of x plus 1 means find the function f and replace x with x plus 1. So let's do that. Negative 2 times x plus 1 squared plus 3 times x plus 1 minus 3. That's all f of x plus 1. Now I've got to do minus, brackets, minus f of x, which is this function as already written. So negative 2x squared plus 3x minus 3. Okay, a couple of things I have to do here. And I'm going to need more room than I have. So let me find some scratch paper. Okay, paper scrap. So, as I'm working from left to right, the first thing I notice I might need to do is square x plus 1. So how do you square something? Well, regardless of what it is, that means you want to multiply it by itself. So x plus 1 times x plus 1. And I'm going to come in and fill in the rest of this in a second. So x plus 1 squared would be x squared plus x plus another x, so plus 2x plus 1. Now I'm going to distribute the negative 2, so that's negative 2x squared minus 4x minus 2. Make sure you take the negative with the 2. And make sure you square before you multiply. Okay, now what about this plus 3x? Well, I'm going to distribute there. Plus 3x, so I'm going to go ahead and skip down to the bottom line. So that's plus 3x plus 3. Then I have a minus 3. Okay, fine. And let's see what happens on this left-hand side. So over here, I've got minus, and then I have a bunch of stuff. Minus all the stuff. So what I need to do is distribute this minus sign. That's going to change all the signs. It's going to make it a plus 2x squared. Minus 3x. Plus 3. Okay. Now that I have this expanded completely into a list of terms, I want to find the ones that are alike. So let's see, are there any other x squareds? Yes, there should be, because I didn't write a square right here. Okay, that's 2x squared. So yes, what happens? Negative 2x squared, positive 2x squared, cancel. Are there any other x's? There's a negative 4x, a positive 3x, a negative 3x. So in total, that's a minus 4x. What about the whole number? There's a negative 2, there's a plus 3 and a minus 3, which are going to cancel each other. And then there's another plus 3. So negative 2 plus 3 is plus 1. Anything else I can do there? Those don't combine, so no. There's my answer. And if I was doing this, I would say, work on scratch paper. So that whoever's grading this actually knows to look at your scratch paper. And you don't say, hey, how'd you do that? Well, leave me a note. Help me out. Number 10. Give an example of a number that is complex but not imaginary. So a complex number could have a real part and an imaginary part, or just an imaginary part. So a complex number, real plus imaginary part, that doesn't have an imaginary part, would just be a real number. So like 7, that's a real number. So it's a complex number, but it is not imaginary. Part B, explain why an integer is also considered rational. Well, because I can write any integer as a fraction. So I could say that in words, like I just did, out loud, or I could say, well, because 7 is the same thing as 7 over 1. There's an integer written as a fraction. Okay, that concludes section 2AB. If you have any further questions, then come see me in tutorials every morning, every afternoon.